coming for the last search party of the year. So I'm Stephanie, I will be your MC tonight. So, the search party. So it's an event for developers, for the community. We organize it roughly every 2 months. We do talks like tonight. We all have great speakers, and tonight is not an exception, you will see. But first, who knows Algolia? Oh, that's nice. Wow. And who has been here before for tech lunch or, wow, search party, well, that's nice. But I will tell you about Algolia either way. So as most of you knows, Algolia is an hosted API that provides developers really nice search, which is really relevant and instant. So you have a user experience where you search as you type. Really modern, really 2080. And finally, about the speakers, because that's why we're here, and for the beers and all of the food. Our speakers tonight, we have Clément. We will start promptly from Algolia. After, we will have Julien from L'Extenso. After that, we will have Alexandre, which is a former Algolia. And for the last one, you may have noticed him, who is he have a really, really nice clothes tonight. And he's from Netherlands. He pinged us on Twitter, actually, to do this talk tonight. And I really encourage you to do the same and come here on stage. We are really well here. So yeah, for the first talk, let's welcome Clément.
So evening everyone, I'm Clément Denoy and I work here at Algolia as a full stack engineer. So I joined 8 months ago, and like everybody else at Algolia, I was given a task to do during the interviewing process. So this is, I will present you the task I was given. So MDN, so the Mozilla Developer Network. So it's a resource developer for developer, maintained by the community of developers. And it contains tons of quality contents, CSS, JavaScript, HTTP, HTML5, and so on. It's a goldmine for any web developers. It contains tons of quality content, navigator compatibility tables, as well as a link to the specification, many other user things. So it's a perfect resource, except, yeah, the search. So the search is not typo tolerance. So if your finger rip on the keyboard and you search Harry with a U instead of a Y at the end, you don't find what you're looking for. Also, no search as you type. So you need to type your full query to find what you were looking for. So as shown on the screen is a result for the for keyword. So I was expecting to find the for statement in JavaScript, but instead I got the first result is Firefox for iOS. So without highlighting, it's hard to know why this result is in the first place. Yeah. Of course, I could narrow down my search using the filter on the right, but I will need to uncheck all the checkbox excepting the JavaScript one. So I don't find it really useful. So a good workaround to search on the MDN is just to use Google. Just type MDN, followed by your keyword, and you find what you're looking for. But still, no search as you type. I mean, excepting if you type directly into Google Chrome, not in the search. And you don't have the syntax directly displayed. So here is the project I built. Not this one. Okay, sorry for that. So you have like typo tolerance. You have search as you type. You have highlighting, of course. And if, as an example, if you type referrer, I don't know, like referrer, I don't think I'm the only one to mistake, but I don't know like how many F and how many R each time. So if I type referrer with 2F, 2R, I don't know. Yeah, I found what I'm looking for. So how it was done. So in three simple steps. So first step, scrape the data. So extract all the things I want to make searchable as a list of structured objects. Second step, push it to Algolia. So as an hosted search engine solution, you need to actually push the data to be able to search on it. And third step, build an awesome search UI. First step, scrape the data. So for this, I use Scrapy, is a framework written in Python. I use it for quite some time now, so it was like kind of the obvious choice for me. So here's an example of like a kind of XPath I had to write. So you have to know, like, since MDN is kind of a wiki, the HTML is sometimes quite messy, and as well the architecture of the information is, yeah, hard to grasp. And here is the extracted record I managed to have. So this is the record for the 4 JavaScript statement, for instance. So you have the tags and the categories. Those will be used for the faceting part. You have the name, the short description, and the syntax. So this, it will be for the actual search. And you have the number of contributors and the last update. So those will be used for the ranking part. Third step, second step, sorry. Push it to Algolia. So the simplest one. So I used the Python client library. So in just 3 lines, I was able to push the record into my Algolia index. So first line instantiate the client, second line instantiate the index, and just third line push the object. Third step, build the UI. So Algolia have like many front-end libraries, all targeting different frameworks. So you have Vue, React, like kind of vanilla JavaScript, and as well as Angular, etc. I choose the React one because it's like I was more comfortable with React. So as an example, you have the hierarchical menu widget from the React Instance Search library. So on the left you have the code, the JSX code, and on the right you have the rendered HTML. So quite nifty. And it's online. So it was my really first project using Algolia. I never used it before, and I was like quite. I work at Algolia, so it's quite. But I was really blown away by the facility, the ease of use, and how I was quickly able to build something using Algolia. So as a final word, I want to say if you work at MDN, or if you know people who actually work at MDN, please let them know. I mean, not for my actual project, but we can help for the search. Thank you.
Thank you, Clément. We have time for question. Who has one? Who want to be the first? Go on, go on. Nobody will eat you.
One.
Ah, we have.
I need to speak. Okay. My question is the first step, you are scraping the data, and I was wondering when and what kind of data you are gonna query, and you're gonna scrape. Is all the data from the MDN, or just the data you wanna search? And each time you search and you scrape the data that you search the data that related and push it into Algolia, or you just for one time you scraped all the data and push it to the Algolia.
So I scrape on a regular basis. My scraper is like I think every week. I scrape only the data I want to look for. So it includes CSS, HTTP, Web API, and HTML, and JavaScript, of course.
The kind of data you wanted to scrape.
I was like I was kind of during my initial investigation of the NDN website. I was like about, okay, do I need to index everything into Algolia? And the answer, of course, is like no. I just want to index what I actually want to the useful thing for the search.
Okay.
So just the syntax, because I want to like quickly find the syntax, and I don't need to go onto on the MDN website to look at the syntax, and of course the actual name of the object, the short description, and the syntax, and that's all. I just want to display this information. So that, like, basically I targeted only this thing because I wanted to display only this thing into the search.
I think my second question is what is the syntax that you define? Is that you right now you just tell me that you're gonna scrape the data in HTML, CSS, and are you gonna scrape all the data within those topics that you wanna scrape, or you're just scrape the data that the words that you type in you want to search?
I just like on Indian, I will show you like. So, yeah, basically, this is like the page for the for statement in JavaScript. I wanted the introduction only, the first paragraph, and as well as the JavaScript demo, just the syntax. That's all. Because I was expecting like the really relevant thing for the search is the name of the object actually.
Okay, thank you.
Thank you, Clément. Feel free to ask a question afterwards. There is plenty of people here. Oh, sorry. You can ask question after. We'll set up the second speaker. And yeah, people in the background, there is plenty of place here, or on the square poof if you don't want to be in the front row. So yeah, you can come. Thank you, Clément. Come, don't be shy. So now we are preparing Julien. Please give him a warm welcome.
Ooh. Hi everyone. So I'm Julien Madio. I'm a digital developer at Lexenso. I'm part of the digital innovation team. And today I'm here to talk about adding real-time voice search with instances.js. Pretty cool subject, right? So a few words about Lexenso, my company. Lexenso is a legal publisher. We are publishing books and legal magazine. about laws and justice decisions. Our main product is Lexenso.fr, which you see here. It is a document database for professional with a search engine, and guess what? It is with the Super Algolia. The main purpose of Lexenso.fr is a knowledge database for lawyers and notaries, basically. It is a professional tool for day-to-day usage. It is also for non-geek customers, that's how I call them. It is easy to understand because our customers doesn't test a feature, that only use it or not, depending of if they understand it or not. So in June, I just received a little newsletter from Algolia who told me that 50% of search will be through voice by 2020, which is very important because you already know that maybe your own customers have a Google Assistant or maybe Amazon Alexa in their own home. So it is a very important subject. So we thought that, yeah, we may have to do something with it. So we wanted to add voice search to our main website, Lexenso.fr. It is a website, so you have to be for the web. You have to be for cross-browser because you have a lot of customers and they actually use Internet Explorer for a little of them. And maybe if you think about progressive web apps, you can understand that you have to be compliant everywhere. So we are looking for a speech-to-text provider. So it's the list of 3 of them that are selected. They are all compatible with the web. You have Google Cloud Speech Text Service, Microsoft Azure Connected Service, and also IBM Watson Speech Text Service. So technically, little details, Google doesn't provide any STT SDK, so you have to build your own with their own technology that Google love to do with is gRPC. So you have to do everything that you want to do and basically your own. So kiss Google, I love you. Microsoft Azure, it changed the endpoint and all the stuff in September, so it just changed for a while. But basically, they have no open source package and they are based on WebSockets to send the audio. You also have IBM Watson with speech text, also on WebSockets, but they have open source package. So you can follow the release and all. You have support from developer. Woo, community. No one. Okay, right. I didn't mention Amazon Transcribe because it isn't in real time as for now, actually, and it isn't. They don't have SDK for the web, so we don't select it. So let's get started with IBM. Why IBM Watson? Because IBM Watson was pretty impressive. As you may know, our clients are lawyers and notaries, so they have very special requests, very special keywords. And Watson was pretty impressive with that. You can customize it, you can send him your own keywords and all, and he just understands everything. So that was pretty cool. So how do we do this? So we started with instancer.js connector. This provides you the possibility to extend your actual widgets. So that is really simple and can act for the search. So if you just receive the result from Watson, you can just ask for the connector to refine the query, simple as that. So basically, it is a very tiny connector between IBM Watson and Algolia, so kind of a middleware. So you can find it here. All right. On GitHub, it is open source, of course. It is open to the community if you want to maybe push something, if you want to do pull requests of everything, just go check it out. It is on lex.so/Watson dash connector. It is very simple to integrate it in your own website. So first you just import it. Just after you just go to the configuration. This is basically almost like what Algolia do with their own widgets. So that's very simple. Watson require a token to be sure that it is you. So this one here, you have an attribute of token URL which go fetch the token for you. You just have nothing to do, but you have plenty of other function here if you want to do your own, and just start using Watson. So a little feedback about Watson. When we implement Watson connector on our main website, we face a little problem. In fact, for a couple of months, we work with IBM support to really understand why we have such a problem. Watson returns us very bad transcription, and we didn't actually know why. But now, today, I can tell you why. In fact, while the it widgets of Instant Search is rendering the page, the actual WebSocket audio just stop. And after the its widgets just have finished it, well, Watson just keep receive the audio. So basically, Watson doesn't have the entire audio at the end, so just have bad transcript, which is kind of logic. So nobody is perfect, right? We are working on it. We're trying to figure out what is really happening. We're not exactly sure there is the hits widgets. The thing that I can tell you is that if you download the demo on our GitHub, it actually works. So we don't know exactly why. It's maybe based on the template. If you have a huge template, HTML template on your hits widget, it maybe have something to do with it. So we are working on it. So we have to find an alternative to this. So we actually know that 50% of our users, use Chrome and not Internet Explorer. So we find a new solution with this, and so I developed a second connector, which is the alternative with Web Speech API, available only on Chrome, on Google Chrome. I don't know why Firefox doesn't have it, but you may ask them. So it is actually available on NPM, on Yarn, and also open source and open to the community on GitHub. So here just a real example of what we have on our search. Just you click, you speak to your own alone with your own computer, and just magic happens. So we will launch this feature in a couple of weeks, maybe more, maybe early 2019, because we are not very satisfied because it is only available on Chrome, and we want to integrate with Watson if we can. So that's it. Come on. So if you're still interested by the voice search, you have to know that Algolia is working on the subject. You have 2 repos on Android and iOS for the voice overlay. So just check it out, algolia.com/solution/voice-search. Thank you everyone for listening, and remember, keep doing something great. If you have any questions.
Thank you very much, Julien. We have time for some questions. Question.
I'll be around with a beer.
Yeah, everyone will be talkative with beer. We have one.
Can I speak in this? Just regarding your comment about Firefox, there's actually a Mozilla project called Common Voice,
Yeah.
where you can donate your voice
Oh.
and create the speech-to-text model for everyone.
Oh,
Yes.
all right. Okay. I didn't know that.
Nice.
Another question.
No more question? Okay. Well, thanks a lot.
Thank you, everyone.
Thanks a lot, Julien. That's your turn. So now Alexandre will come for his presentation. So don't stop clapping, and welcome Alexandre. So it was previously at Algolia, and we will talk about Algolia, obviously, and Spotify, which is great too. don't hesitate. There is still place in the front row. You will see better here.
Can you hear me? Hey, Tim. Okay, can you hear me well? Yeah, cool.
Yeah,
Thank
perfect.
you. Hi, everybody. Today, I want to talk to you about Playlist Detective, a pet project of mine, which is an alternative search for Spotify. Obviously, I'm Alex. I'm a software engineer. You can find me on Twitter at Bobilito. And one thing that I can tell is I love music. More specifically, I love discovering music with playlists. And one thing I can say about Spotify search is that it's great. Here, the talk is not about saying that Spotify search is meh. Actually, it's quite great. It supports, it's quite relevant. You can do typo tolerance. It's quite fast. You can search into multiple things, songs, artists, even playlists. But it's not that great for playlists. You can't really dig into the playlist. You can't really refine by artists that you want to specifically in playlist. So that's why I made this tool, which is called Playlist Detective. And let me try to do the demo. Yes, it works. So this is it. It's a search, as you can see. And for example, if I want playlist with Umbrella, a song that I love, oops, you can search, add Umbrella. So all the playlists which have Umbrella in their playlist will pop up here. Same thing with the artist. For example, I love Kanye. Of course, Kanye. Boom, I have the, it's searching. And now I have the playlist with Kanye and the song Umbrella from Rihanna. So that's it. Now let's talk a little bit about the implementation. Of course, like any search implementation, you have two parts. The first part is indexing. Here the data will come from Spotify themselves. They have a very great web API. So let's see how it goes. In my case, I want to download playlists, and so I need to get them from Spotify. The problem is that you can't get all the playlists of all Spotify, so you need to have the user ID of a curator that you like the playlist of. So of course, I've built on my end a list of curators. And once you have the curator, you can get their playlist using this endpoint. Then once you have the playlist, you need to get the tracks in order to get the songs and the artists. And then you also need to get more information, such as the number of followers that you will get from the playlist itself. So it's yet another endpoint. So all of that is pretty cool, but it's a bit tedious because it's paginated, like you would expect in any web API. And also, there is a rate limit, so you have to handle that, which is a lot of fun. And of course, it's a pet project, so I don't have much time. So I first went for a first iteration, which was a bit quick and dirty. So in this implementation, I have a first script that actually fetches the data from the Spotify web API. And for each of the curators that I've selected, I create a file, a JSON file, yes, very dirty, that I put on the disk. And after that, I read all those files and I push to Algolia. Why do I split those in two? It's because if one part fails, or if you want to do test or redo the indexing, you want to keep something in the between. But it was really sort of run and trash everything kind of mentality at this point. So it's great when you have very few curators. Actually, when I began this project around the beginning, I had only 150 curators, which was fine. I had a couple of hours of indexing time. I did the indexing every few hours. It was fine. But then I find a way to find a lot of curators, well, 10 times more, and it was a mess. Really, the idea is that it didn't scale well because I had this fire and forget kind of mentality. I was not smart at all. So I tried to do another iteration with a database in the middle. Woo! High technology. So I use MongoDB obviously for simplicity's sake. And the idea is that if I saw that the playlist was not updated, I wouldn't go and fetch the tracks and stuff like that. So it was much faster. And actually, if you every time I rerun the indexing or the fetching of the playlist, I have like very few playlists that are updated, and actually those are mostly the Spotify playlists. Then you push to Algolia. It's basically the same. Instead of reading files, you read to a MongoDB database. And yeah, so that's it for the indexing part. Searching, so the UI. Obviously, I use Instant Search.js, well, Instant Search, and more specifically Instant Search.js because I worked on it. And I use a couple of widgets. And I think that's pretty cool to see that, because you only need a very few widgets to actually build a search UI. That is, I think, pretty cool. The search box, some refinement list, and some infinite hits widget. One thing to say here is because I wanted it to be mobile compliant, so I had to do some sort of drop downs. So I had to do some custom code for that. But that's about it. The rest was templates and stuff like that. And one thing that sets apart actually this search interface is the use of search for facet values. What is search for facet values? It's a feature that lets you do a search into your search. Yeah, actually it lets you search in the list of facets if you have lots of them, which in this case is quite a lot because you have all the artists and all the songs, and you have like lots of artists and lots of songs. So you want to search into them, especially if you are a user that knows specifically that kind of stuff. So yeah, really, if you don't know search for facet values, you should dig into it, and it's built in Instant Search, all the Instant Search. So what now? First, some key learnings. Really, what's interesting is that you can really build a search that is really specific to some kinds of users. There is no one good search. Well, there may be a good search for most of people, but you can also do a search for niche people like that, and that works great for those people. Also, it's fine to start with something that will break eventually, because at least you get to see and validate your proof of concept. And also be ready to improve. Don't be lazy on that. Next, I want to play with custom rankings, because right now I'm using a number of followers. But obviously, if I want to find some sort of niche playlist, I want to do something more smart about that. And for that, I will try to leverage more the data set and do some data analysis on that. Thank you. If you want to go and see Playlist Detective live, you go to playlistdetective.com. You can find it on GitHub. Please find out. Yes, it's not the same name. And you can ping me on Twitter. And also, one more thing. It's mobile first, sort of. It's a PWA, so you can install it on your phone and have it as an app, which is super cool, and it integrates well with Spotify. Thank you very much.
So, is there some question?
Hello, thanks for the presentation. It's really great project. You said that you were doing the indexing automatically every few hours. How do you do that?
So, okay, I used to do that because now it's more it's more of a setup, and I'm a bit cheap, so I don't want to pay for hosting. So I'm doing that on my laptop. I can do that. Well, I would do that every now and then. But before I used Heroku, they have like this sort of cron system, which works fine for a fire and forget kind of script.
Other questions?
I'll be there. I'll be around afterwards.
Yeah, don't worry, we'll be there. So,
you have a question.
How can you update your MongoDB database with updated content from your curator if he updates his playlist?
Okay, so that's a cool thing. Good question. Actually, each playlist you have an ID, and also you have some sort of revision name. So if the revision name is different from the last one, it has been updated. So I will do the fetching again.
Okay. Thank you.
You're welcome. Thank you.
Thank you very much. And for the last talk of this night, Peter. We really, really appreciate the effort on the close.
Yeah, it's working? Cool. I'll put this here. Yeah. So, Julie, wait. You are the only one without a Christmas sweater. I got an email saying you need to put on a Christmas sweater, and now she doesn't have one. So here you go. Okay,
Well, you deserve it. Thank you, Peter.
All right, some extra decoration because there wasn't enough, so I brought a little bit. This is about Algolia and Magento 2. Who knows Magento? Some hands. It's an e-commerce framework written in PHP, but it's fine now. It's fine now. Oh, wait, it's zoomed in a bit. Oh, wait. Now we go. I have to scroll. Sorry. Can we do this better? Wait. Yeah, okay. This is easier. So it's a little bit smaller. Mooi, that's our local hi from Groningen in the Netherlands, where we're from. It also translates to I in French, so that was funny. I'm Peter. I run Algentos with 12 of my colleagues, of which one of them is Guido. He's sitting there. We built this thingy. I did the back-end part. Guido did the front-end part. So I'll also explain about the front-end part, but questions for front-end will be directed to Guido. Case study. It's about our client, All for Honda. We're building a part finder. So what does All for Honda do? They sell car parts for Hondas, for Honda cars, like this one. Guys who tune it, they need a lot of parts to tune it because apparently they're not good when they come from the factory. So they have a lot of tuning parts. One of the problems is a lot of products. They have about 16,000 products all in their warehouse. And that's a lot of products to know which product will fit on what Honda. The second product is that the problem is that they have a lot of suppliers. This is just a part of them. They have about 150 to 200 suppliers, mainly Japanese suppliers, who apparently have no idea on which of these cars their products fit. So you have an exhaust. Yeah, here's an exhaust. Oh, does it fit on a CRX? I don't know. Does it fit on an Acura? I don't know. So that's a problem. But it was all in their heads. So the guys at All for Honda asked us to come up with a solution to make this data in their head presentable to their clients who want to buy auto parts on their web shop. So our solution was based on Magento with Laravel and Algolia. Sorry, again, PHP, but yeah. So this is what we built in Laravel. This is the part finder tool, in which on the left side, you'll see a list of product parts that are in Magento that are pushed to the Laravel application. On the right side, you'll see a list of cars on which the parts will probably or maybe or definitely fit. So the guys at All for Honda, they have that all in their head, apparently, and they know exactly, oh, this is a start motor for a Civic Del Sol, and it will fit on a Civic Del Sol from 1999 to 2001, but not the 2.0, but the 2.1 liter engine version. So we tried to, a little bit back, we tried to build a tool so they could make their knowledge explicit, from in their head to a database. So their data flow went from this, is now this. You put in a basic product data into the web shop, which is run on Magento. Then we push it through the API to the part finder, which is built in Laravel. Then we enrich the data, so make implicit knowledge explicit. We put that in Algolia. And then the Magento extension, Magento will take that data from Algolia and show it on the front end. We do pushing from Magento to Algolia. The heavy work is done for us with the Algolia Search Magento 2 extension for Magento 2, which is written by Jan Petter. I think he isn't here right now, but he's our hero. It's a great extension. The magic sauce in this thing is called hooks. So the Magento 2 extension written by Jan Petter has a few hooks. So they have front-end hooks and back-end hooks. And the front-end hook is the Algolia, which we use, by the way. There are multiple, but we use these two. The front-end hook is the Algolia hook after instant search start. So it's a lot of type. And the back-end one is the Algolia after create product object. So how do we use these? This is in Magento. This is an event Magento is event-driven. So this is an event in Magento that is called when a product is saved, and it will run an observer, and that will take the information from the part finder Laravel tool, append it to the product object within Magento, and then push it to Algolia. So our first implementation structure for the data type was like this. So we had a make, which is always Honda, so only one. Then we had a model, which is in this case either Civic or a CRV. Then a year, 99 and 2003, engine types. And we tried this, but the problem is because of the way Algolia is written, and the reason why it's fast, we eventually found out, is because it doesn't support nested and/or queries. So we couldn't do give me Honda and Civic or Honda and CRV. That wasn't possible because of technology. So we had to find another way. The other reason was some combinations do not exist. So we could make every permutation available from these data points. But for example, a 2001 Honda S2000 does not exist, or a Honda Civic 1993 with a 1.6 liter engine doesn't exist either. So that became a problem. So we cheated a little bit. Actually, we felt it was like cheating, but apparently Algolia does this all the time. It's a thing we saw in one of the presentations before as well. It's the level 1, level 0, level 2, level 3 way to build up stuff. So we built up a level 1 search engine, which is the make query clause. And then we had the level 1, which is the make and model, and the level 2, that is the make, the model, and the type, year, sorry. And then the level 3, which is the make, model, year, and engine. So in Algolia, we eventually got this data, in which it first said it's for a Honda, then it's for a Honda Civic 3-door hatchback, and then it's for a Honda Civic 3-door hatchback from 2001 to 2003 and to 2000, etc. And then with all the engine types, so kind of exploded. This is the JavaScript implementation. This is where we added a widget through one of the hooks, the Algolia hook after instant search start hook. So that is triggered in JavaScript, and then we add a little bit HTML to it, and then we have some triggers set on it that will read out the input fields and then pass on the query to the Algolia search engine and give us a result. So this is, you'll see here, this is the search bar. It's a Honda S2000, 2004 to 2009 2.0 liter, and then it will filter all the product that will only fit that car, because otherwise you'll get a lot of cars. So let's see if I can. Oh, French keyboard. Nope. Wow. Okay. Got it. Thank you very much. Interior, let's get the seats. Oh, well, the seats are mostly universal, so let's get lighting. And so if I select a model here, let's say a CRV, and it will change. And it's so fast. It's so fast. Check it out. It's so fast. Wow. Oh man, I couldn't get over how fast it is. I'm from PHP, you know, so it's just, it's like, wow. I didn't know technology could be this fast. So that's great. So within 10 milliseconds, all products are filtered, and this means we're 10 times as fast as the competitors because they still run on PHP without Algolia. So we're very fast, which is nice, and our client was very happy. Our roadmap, keep working on the Algolia Magento 2 extension, which is great. Did I mention Jan Petter? He built it. He's awesome. We do a lot of PRs for it and fix it with him, and he's really nice. It's great. And we wanted to refactor the part finder to React because we found out state management in jQuery is hell, and you know all the cool kids do React. We did PHP, so we want to be cool as well. So React. Thanks.
Do we have questions for Peters? Are you on beer? This is it? Ah, question.
Hey there, I have a question which might be a little bit more for Guido, but I was just wondering how you implemented the main bar. Is that a custom hierarchical menu, or is it something else?
Yeah, it's just a field with drop downs. So let's
Okay.
See, the data is not hydrated from Algolia, it's hard-coded in the jQuery
It's hard-coded
code.
to JSON
Yeah.
object.
Because
Okay.
we only have to update it when Honda releases a new car, which isn't that often. It's not BMW, so
Well, if you're interested, you could actually make this with a custom hierarchical menu. I can explain it afterwards if you want to.
nice.
Somebody else have a
questions?
question?
Come find me and give me a beer, and then I'll answer more questions, also not tech related.
Thanks a
Okay.
lot, Peter.
Thank you very much.
Well, thank you everyone for listening carefully. You now have the right to drink vin chaud, to play flipper, and to take plenty of photos because we have a photo booth downstairs, this way, in the back. Thank you all.